start. Now here we're going to deal with the topic of ionization energy. So here the topic is ionization energy. What is the ionization energy? Suppose you have an electron, okay? This is your nucleus. That is your first orbit, okay? And so this is the hydrogen atom, and this electron that is there over here, you have given some amount of energy, and this electron is removed completely from the nucleus, okay? So this is a hydrogen gas, okay? So we will say the amount of energy required to remove an electron from ground state, okay, of an isolated gaseous atom, okay. This is the important part, okay. It has to be a gaseous atom. That means if you have, say, solid, we all know that Na is a solid. If you're giving it heat of sublimation, these kind of things you will learn in thermochemistry while we will calculate the lattice energy, okay, using Hess's law. So it is forming sodium gas. If you heat it, it will sublime, okay. Sodium will sublime and it will form.
Sir, can you pull up the page?
Okay.
Okay, sir.
Now, suppose you're giving certain amount of energy over here, okay. This energy is your ionization energy, okay. So when we are talking in terms of energy, we will call it as ionization energy. Sometimes it can also be reported in terms of voltage. Then we call it as ionization potential, okay. Understood? Yeah. Now, this is the sodium gas. It has one valence electron, say, in the outermost shell. We all know that sodium means what? 1s2, 2h2, 2p6, 3s1. Suppose we are dealing with one sodium atom like this, okay? And we have heated it, so it is subliming to form the gas. So it is becoming now a isolated gaseous atom, okay? And then you are giving certain amount of energy for it to form a ion and release one electron to an infinite distance, okay? Now, this energy that you are giving for it to go out of the valence shell, this energy, this is called the ionization energy. Now, तुमने energy दिया, right? You are supplying energy. So if you consider sodium to be some system and you are supplying energy, so it is taking energy. That means the energy is coming to the system. That is why it is endothermic process, okay? So you remember this is a endothermic process. When you supply energy to the system, thermodynamically we call it as an endothermic process, okay? Now, suppose you have given some energy over here, which is in terms of h nu, and then the electron is going away, say to this n equal to infinity, and here the n is equal to 1. Now, if you use the equation, okay, what equation? E equal to h nu, isn't it? And we say plus 13.6 okay, Z square, isn't it? And that is
Yes.
what? Ni square by Nf square, where Ni square is indicating it is the what? Energy level 1, and Nf is indicating what? Infinite level, okay? So in this equation, then you can say the value of Z is what? Equal to 1, isn't it? Everybody agreeing?
एक नीचे ना हो सोडियम একটা দেখবা
দেখো।
হ্যাঁ স্যার ঠিক আছে
ঠিক আছে?
হ্যাঁ
Okay, so we can say this to be as 13.6. Alright, Z value is 1, isn't it, Bolo?
yes sir
And in the equation, what we will say? Ni square, Bolo, by
yes sir
infinity's square. 1 by infinity is what? We can write mathematically 0. So this thing now becomes what? Plus 13.6 EV by Ni square. Can we write this, Bolo?
yes sir
And since we know the value of Ni square, Ni is equal to 1, so this becomes plus 13.6 EV. Everybody is agreeing?
yes হ্যাঁ স্যার
Okay. Alright, now you have to understand. So this energy is now what? So you will call this energy to be the ionization energy. The energy that you supply to take the electron from this level to the infinite level will be called as the ionization energy, okay? So to remove an electron from the hydrogen atom to this infinite distance, from here to this infinite distance, we will call this as to be the ionization energy, and that is now having the value plus 13.6 EV, okay? Understood?
yes
Okay. Now let us go into something else. So we can say that, alright, fine. So we know that the ionization energy to take out an electron from the hydrogen atom is plus 13.6 electron volts. Okay. Now if you want to convert this into joule, what will you do? If you want to convert this into joule, what will you do? You will just have 13.6. Okay. You know the value of 1 EV, right? What is that? 1.6 into 10 to the power what you say?
minus 18
18 or 19?
9
19. Okay.
12
Joules. Agreed?
yes
Everybody? Okay. Alright. So that if you multiply, you will get the answer. Alright. Now, what it means if 13.6 EV is given to a H atom, electron just comes out, okay? Just comes out of the atom. So this is the minimum energy that is required to take out an electron from the atom. Again, by definition, if you say ionization energy is what? It is the minimum amount of energy required to remove an electron from ground state. Okay. Again, if I say I am giving 10 electron volts, do you think the electron will come out?
no
No. So we will say electron does not come out. Okay. If I give 15 electron volts, do you think the electron will come out?
Yes.
Okay. So what happens to the rest of the energy? Electron comes out, okay, of the atom, isn't it? And with
Yes.
some kinetic energy. What is that
Yes.
kinetic energy going to be? What is that kinetic energy going to be? Okay.
1 1 2.
Yeah. So you will say 15 what? Minus
Sir,
13.6. हाँ बोलो.
इलेक्ट्रॉन कम्स आउट ऑफ एटम, उसके बाद ये के
हाँ.
के पहले क्या लिखा है?
With.
ओ ओके 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 सर ओके.
Okay. So this is 15 minus 13.6. It's almost like the equation that you had used in the photoelectric effect. You see,
Yes.
isn't it? There we had h nu the supplied energy and h nu naught was the energy required just to take out the electron. Bolo yes or
Yes.
no?
Yes.
Okay, fine.
Yes.
Okay, fine. So if you do that, then we can solve this thing and we can say the rest of the energy, that is 1.4 electron volt, will be our kinetic energy. Yes or no?
Yes, sir.
Okay, fine. Now what happened? Okay. So let's do one sum. ठीक है बच्चों, देखो,
And
find the ionization energy for He plus. In the DPP that I've shared, you will see, if you follow the last uh, previous year questions, which we obviously called as archive, then you will find a lot of questions are coming from ionization energy. In fact, in the DPP, I have not removed the years. So if you, yeah, so today you can try the DPP. I think you will be able to do it. And many simple questions. You will see most of the questions are very simple. Okay, from this chapter. So it is only little bit of practice that you require to solve these questions. Okay, and keep using the technique I've showed to you, that you don't need to remember the entire formula. You just need to remember which things vary. Okay, so for this one, I have said find out the ionization energy for He plus. Okay, ionization energy for He plus. What will you do? You have the equation of ionization energy. Okay,
yes.
all right. You know He plus is also like hydrogen like system,
Yes, sir.
but the Z value is different. So what is the Z value over here?
2.
Right. N value is what? Ground state is 1 again.
1. Yes.
Okay. So this is your Ni, isn't it? We don't require
Yes.
the, yeah. So we will say again what? Plus 13.6, isn't it? Z square by Ni square, isn't it, Bolo?
Yes.
Okay, fine. Now it will be what? Plus 13.6 into 2 square. What will be the value? Ni, you know it is 1, so you don't need to consider Ni now. What is this value?
54.4.
54.4. See, it is a very simple sum. If your concept is very clear, it is very simple sum. Alright. One thing you should also remember here, that ionization energy is always having sign opposite to that of energy. Okay. Ionization energy will be having the sign opposite to that of energy. Do you agree?
Yes.
Because if you remember, if I said find out the ionization energy for the level 1, for, that is E1 for hydrogen, you will say, sir, the value is minus 13.6 EV, right? Bolo yes or no?
Yes.
And
Yes.
here if you see the value for ground state ionization energy is what? Plus 13.6. So from here only you can understand. And there was a question again, in the IIT regarding this. Okay. Question I'm writing for you. Just have a look. Which of these options are correct for IE and E1 for H atom? Okay, and the options were 13.6, comma 13 point, sorry, 6 EV. Option B, minus 13.6, comma minus 13.6 EV. Option C was minus 13.6, comma 13.6 EV, and the D option they gave 13.6 minus 13.6 EV. Understood how the questions may come? Okay, fine. So what will be your answer here?
D.
Yeah.
D.
Now again, as we have been doing questions, this was a question again asked in the medical exam. Okay. So question is, if 13.6 EV is needed to form H, then find the amount of energy required to form Li plus from Li. ठीक है, ट्राई करोगे इसको?
Yes.
करो.
So 122.4 electron volt.
122
0.4.
मैंने 13.6 इंटू क्या हुआ? 9.
Yes, sir.
Okay, fine.
Yes, sir. 13.6 into 9.
Right. Yeah. So it will be ionization energy Li. यही किया हो ना?
Yes, sir.
13.6 फिर क्या लिखे हो बताओ?
Z square by Ni square. Z square by Ni square.
Okay. Z square
Z,
by,
Z is 3 and N is 1.
right. So 13.6 into 9, and this is obviously 1 square. ठीक है ना बेटा?
Yes.
Yeah.
Yes, sir.
A very simple sum. So it came as 122.4 eV.
Oh,
Okay, let me keep this in black. ठीक है, तो ये easy sums है, देखिए जरा. It is not so difficult to do. Now, what we are going to do, we are going to find out the difference of energy between two levels. We have already done it previous class, right? While we were calculating how the energies
yes,
vary.
sir.
Remember that
Yes,
E1 to, yeah, E2 minus E1, then we did this kind of things we did, right?
yes,
E3
sir.
minus E2, right? And we have shown that how the energies are reducing as we go away from the nucleus, okay? The
Yes,
successive
sir.
gaps, energy gaps, they reduce. So separately we are doing this thing again. So this is we are calling as separation energy. Just to, it is not something very new for you, it is already something you know. So it is the amount of energy required to remove an electron from ground state to excited state, okay? My mom today sprained her ankle.
How, sir?
She was just trying to go a little away and then basically went to the neighborhood to give them something. And while she was returning back, then she sprained her ankle. ठीक है ना? ताले suppose we
Yes,
are
sir.
having these three levels which are N1, N2, N3, and suppose there is electron over here, suppose, okay, and you give some energy, okay, so the electron jumps to this level, suppose, isn't it? The
Yes,
electron
sir.
jumps to this level, so this gap of energy, which is obviously E2 minus, okay, E2 minus E1, okay,
Yes,
suppose
sir.
this gap of energy we are saying, or let's say this way, let's say this way, we are, sorry, pen is getting stuck today, wait, let's say that the electron, we are giving this energy and the electron has gone away to the excited state, okay, infinite distance, ठीक है ना?
Yes, sir.
Hmm. It has gone to this infinite distance. All right, so what we can say is that, say suppose this is for a hydrogen atom, okay, so we will say that SE1 is nothing but E infinity minus E first excited state, okay.
So 8E1, na?
Hmm.
Oh, no, 8E1. Okay.
Hmm. And this is nothing but E infinity minus E2. So let's call this as the amount of energy required to remove an electron from its excited state, not ground state, okay? Only excited state. So we know that E infinity is nothing but 0, isn't it? And
Yes, sir.
the energy of E2 is what? Minus 3.4. Is it clear? Not clear.
Yes,
E2
sir.
E2 is what? Minus 13.6 by kya? N square, na?
Sir, how?
Yeah.
Sir, how E2 is minus 3.4.
I'm telling you, right? 8 आना बोलो कोड़ा देखो.
Yes, sir. Oh, okay. Fine.
Okay. Understood ना?
One again.
हाँ.
Yes, sir.
Is it raining at your place?
Yes, sir.
Okay.
Yes. এখানে বৃষ্টি হচ্ছে।
My ear is not that bad, okay. While you, yeah, so you almost, the difference between two students over here is around what? Someone is in Howrah and somewhere is in the North Bengal. So it is almost like what? Over, over 400 kilometers. That is a huge difference. So can you tell me what is AC2?
minus 13.2. 0 minus 13.6 by 9.
So this is, say, this is your ground, this is your AC1, okay. This is your AC1 and that is your AC2, okay. So it is basically what?
Plus 1.31.
Okay, very good. So it is SE2, that means it is the second excited state, right? So it is E infinity minus kya? Second excited state. ঠিক আছে? Spondon, sadly,
Yes, sir.
some books are not covering this topic, but sums are there.
Yes, sir.
Okay. So 0 minus of minus 1.51. Now, why it is 1.51? You can calculate obviously. What will you do? E3 kya?
Yes, sir.
Minus 13.6 by kya? 9?
13.6 by
9?
999. Good number.
So 3 square, na? I think I need to change the nib for this stylus now.
So to change the
Yeah, you can change it. Okay, so it is basically now what? 1.51 EV. Let's do excitation energy. Okay, so separation energy we have understood. What is excitation energy then? I just want this to not disturb me today. এখন চেঞ্জ করতে হলে অনেক ফ্রি হয়ে যাবে। Now what is this energy? Amount of energy required to excite an electron from ground state, okay, to higher energy level, okay. ঠিক ठीक है ना?
Okay.
All right. So now we are going to discuss. I discussed about this in the first class में मैंने किया था ये, ठीक है? So it was like called emission spectra. Okay.
Yes, sir.
All right. So over here, spectra means appearance. Okay, how it looks. All right. And if you remember that we had a prism, isn't it? Then we had a screen, isn't it?
Yes.
There was a light, got deviated, okay, further deviated, okay. That is, it was emerging from prism like this, okay. All that theory we have discussed, okay. And this is your screen, that is your prism, and we said we were getting some lines, okay. Say here, here, like that. Now, sometimes you come across a term called monochromatic. Now, what is the meaning of monochromatic? Any idea?
No, sir. Single color.
Single will then, right? So mono means single, chromo means color, so it is basically meaning what? Single wavelength radiation. नीलोफर समझ में आया ना तुमको?
हाँ सर.
Okay. Okay. And I think the next thing I've also discussed type of spectrum before I have discussed. Okay. Type of spectrum. So I'm just re-mentioning this thing to you because we were going to use it. So we have said before that there is something called absorption spectrum and emission spectrum. Okay. बच्चे पार्टी बोलो.
Yes.
Okay, so we had a source of light which is visible light. Okay.
Sir, absorption and emission.
Yeah. Both are different. I'll explain. So you have this white light. Okay. Again, you're passing it through a pinhole. This thing, na, it means this is a pinhole. So that you get only one single point or ray of light like that. Okay. And then again, it is bending, further emerging. That is your screen. And I said this is a continuous spectrum. Okay. Remember? So this thing that you observe over here, okay, this thing that you observe over here, isn't it?
Yes, sir.
Is your that 7 colors? क्या है ना?
Yes, sir.
All right, yeah. And this is a continuous spectrum. Okay.
Yes.
I have mentioned this to you before. So all the colors are appearing over here. Okay. Now suppose, see, you're getting this continuous spectrum. Okay. Now suppose you have a white light again. We have a white light again. All right. and you have some substance that is absorbing some light. You have a substance that is absorbing some portion of the light over here. Okay, so में आ रहा है ना? Some light means some colors are being absorbed over here. Okay, and then you pass it through a slit. Again you have a prism. Okay, it is going like that. All right, and again if you see the screen over here, suppose over here you are getting what? You are getting all the colors. Okay, which is like V, I, B, G, Y, O, R. Okay, that means the entire colors that you see in a rainbow. As simple as that. Okay, but out here, when you see these colors over here, you only can see, suppose you can only see some colors. Okay, say I, G, O, like that. Only this type of colors you can see. That means selective colors you can see, not all of them.
So why IG only?
I'm saying just.
মানে অন্য কালারও হতে পারে।
No, you can have red, you can have only blue, or any shade of.
So তিনটাই হবে এমন কোনো ব্যাপার আছে?
No, okay, you can only have Geo.
Okay.
No, it's not a big deal. Okay, what I'm trying to say that you are not getting all the colors, but you are getting only certain bands. Okay, so this is not a continuous spectrum now. This you will say as a discontinuous spectrum. That means this substance that you are having over here, it is absorbing all the rest of the colors and only releasing only this green and orange type of color. Okay, understood?
Yes.
Okay.
Yes.
All right. So this is your absorption spectrum. मतलब क्या? You know that this particular substance is absorbing certain portion of the white light and only giving you the other set of colors. So these colors it is not absorbing, the rest it is absorbing. Okay. Understood? Yes or no?
Yes, sir.
Okay, fine. Now I also said this to you that for each element, while discussing, if you remember, before I had mentioned that Rydberg equation. Okay, I had said that they were taking the spectrum of hydrogen and then they took the spectrum of other elements and they found that each atom was having a different spectrum. So that means that spectrum that you are getting for each atom, it is characteristic of that particular element, right? So
Yes,
here
sir.
I will say line spectrum. Okay, for each element is different. So sometimes this can come as a statement. Okay, this can come as a statement and you can be asked, okay, that is the line spectrum of each element different? You will say yes. So we can say it is almost like a fingerprint, like your hand print, মানে তোমার হাতের রেখাগুলো যেমন, it is different for everybody. So every line spectrum is like a fingerprint of an atom. बोल सकते हैं ना? जैसे तुम्हारा डीएनए अलग होता है, हर किसी का डीएनए अलग है, right? In that sense, yeah. So we can say that the line spectrum is like a fingerprint, like a fingerprint of each element. So this is how powerful your atomic spectrum is. Few more facts. Okay. If the number of electrons in an atom are same, then the line spectrum will be same. Will be similar, Brodich. चलो. ओके. ठीक है ना बच्चों, बताना.
Yes.
ओके. तो यहाँ से कुछ और चीजें हम लोग जानेंगे. जैसे कि अगर मैं पूछूं तुमको, क्वेश्चन है यहाँ पे देखो. Which shows line spectrum like that of H. ठीक है. क्वेश्चन नंबर ऑप्शंस है यहाँ पे HE, 2 है Li प्लस, 3 है H प्लस, B3 plus. I have said if the number of electrons are the same, then the line spectrum will be the same. So you just use that principle or similar. How many electrons are there in helium?
7.
Right. So it is basically hydrogen or hydrogen-like atoms will be giving this similar type of line spectrum. So if I have given you hydrogen, then you have to consider that Be3 plus is going to have only one electron in the system, so it is a one nucleus, one electron system, just like hydrogen, and so we will be having a similar type of line spectrum. ठीक है ना?
Yes, sir.
Okay. Now, line spectrum.
সে Li plus এ হবে না?
Li plus মানে কত? ইলেকট্রন বলো.
2.
দুটো ইলেকট্রন না?
And hydrogen has 1 electron.
क्या? জীবিত.
Li. Not just I need to concentrate on the
ঠিক আছে. So now at last, today's last topic is, okay, I'll not discuss more than this.
Se kya na?
अरे last topic for today I said.
Oh.
तो हमेशा डरता क्यों है? I'm not going anywhere. तो hydrogen spectrum, I had already explained that this is a discontinuous spectrum. If you remember that diagram of mine, I had given you a tube, okay, and it was connected to some wire. This is containing hydrogen gas, I said to you, remember? And you are
Yes, sir.
giving this electric discharge, okay. I had explained what is happening in between this now. This hydrogen atoms are going to go, hydrogen is going to go hydrogen atoms. So it is getting excited, okay. And so this will now give out electrons forming this, okay. So these are the excited ones, or they can simply come to the ground state by giving out energy. Remember? सबको पता है ना ये सारी चीजें, ठीक है? All right.
Yes, sir.
So this is all discussed, okay? I'm not drawing the spectrum again for that thing. So now, what you need to understand over here, is that obviously when this energy was taken and it was passed through its prism, this particular light that is coming out is passed through a prism. Again, we are getting this, sorry, these things were already discussed when I was discussing continuous and discontinuous spectrum. Okay, now this particular screen, if you see these lines, I said only certain lines were visible to us, not the entire uh, line, as we see in the case of visible light. So only certain lines were seen. Okay,
Yes.
remember, and that is what is called a line spectrum. Okay, so line spectrum obviously appears when you are exciting the atom, right? ये
Yes,
clear
sir.
है ना? हाँ. So we will say this thing over here. Line spectrum is given when an atom is excited. ठीक है? So that needs to be understood. So now we are going to discuss something very fundamental, and you will again see in the DPP that I have given a lot of sums
Yes, sir.
regarding this. Now, instead of drawing a circle, I'm just taking one portion of that circle. So what I'm trying to say here, students, please understand. Suppose I can have this circular orbits, okay, like that, and so on. Okay, the circular orbits are there. So I'm not using these now. Okay, I'm simply saying I'm taking a portion of it. So that portion will appear to be flat. So suppose my nucleus is somewhere here. Okay, so this is the nucleus. Okay, this is the level. What should I say? 1. Okay, now.
Yes, sir.
And suppose this is the level 2, and as you see the gap has already reduced, isn't it?
Yes, sir.
Then we have another level like that, then we have another level like that, then we have another level like that, and suppose this is the infinite level. Okay, if you remember the picture that I had shared in my lecture series, you will see this kind of a picture there. Okay, and you will see a lot of closed lines like this. Here the
Yes.
gaps are very minimum over here. So this type of lines are called a band, okay? Because very closely spaced energy levels are here over here. Something like that, okay? Now one can think that these transitions can happen. Suppose your electron got excited here, so it can come from here to here, bolo yes or no,
Yes, sir. Yes, sir.
or it can come from say here to here, bolo,
Yes, sir. Yes,
or
sir.
from here to here, or from here to
Got it.
here, or from here to here. This type of lines you can get.
Yes, sir.
Okay, and suppose from this, so many things I'm going to talk here regarding this, from here to here.
Sir, can the electron come for infinite also?
Yeah, it can. Why not? I'm saying maybe to not from infinite, or it can also come from infinite. It's not a big difficulty like that. Okay, so
Okay.
so you're talking about a distance that is, see, infinity. Nobody can imagine what infinity is. So distance that is not measurable, we say it is infinity. Okay. So if it is coming from that, okay. For atomic
Okay,
dimension,
sir.
yeah, you can think what is infinity, right? Atom is so small. So like that, 4. These are all theoretical jargons, okay? So if it is coming to this energy level n1 all the time, समझे ना क्या बोल रहा हूँ?
Yes,
If
sir.
it is coming to the energy level n1 all the time, then it is called what? Lyman line.
Yes, sir.
So if I say Lyman line, please understand, that means it is coming to energy level, okay, n1
Yes, sir.
from, so this is ni suppose, and this is nf, so it is coming from 2, 3, 4, 5, 6. ठीक है बोलो.
Yes, sir.
अच्छा, now you have to understand one thing out here. When it is ni is 1 and nf is 2, this line we will say the first Lyman line. Clear है बोलो?
Yes, sir.
Hmm?
Yes, sir.
Okay.
Yes, sir.
If it is this, so this is the smallest energy gap.
Yes, sir.
So this is going to correspond to energy minimum बोलना. मतलब ये फ्रीक्वेंसी मिनिमम भी होगा, तो ये वेव नंबर मिनिमम भी होगा. बोलो. और लैम्डा के लिए क्या कहोगे? लैम्डा मैक्स कहोगे ना.
Yes, sir.
तो आपको जो सम पूछा जाता है, तो वहां पे कभी कभार सम बोलता है व्हाट इज द एनर्जी फॉर द फर्स्ट लाइमन लाइन. So whenever they are saying the energy for the first Lyman line, you have to understand they are talking about the energy differences between N1 and N2. ठीक है. This is also called the alpha. This is also called the alpha line. ठीक है ना बेटा? अच्छा.
Sir.
Whenever I am talking about a line that is N1 and this is 3, अगर ये फर्स्ट लाइमन लाइन है तो ये क्या होगा? सेकेंड लाइमन लाइन. बोलना.
sir.
अच्छा.
NI এখনো 1 ই আছে না?
NI 1 ही है. NI यहाँ पे चेंज नहीं करेगा. अगर ये है इसको लिए हैं, और अगर हम 4 को लेते हैं, बताना जरा. इसको लिए हैं और हमारा यहाँ पे 4 है, तो ये क्या कहेंगे हम लोग? थर्ड लाइमन लाइन. So that is how in your exam they will ask you or confuse you these kind of questions. First Lyman line energy क्या है? Second Lyman line energy क्या है? या Lyman lines first, second and third में energy variation कैसा है बताना. Arrange them in the energy variation. ठीक है? क्लियर है ना? अच्छा, क्लियर है ना सबके लिए ये बात? बोलो. ठीक है. अच्छा. तो ये तो यहाँ पे ये समझ में आ गया कि सर N1 अगर होगा और ग्राउंड स्टेट मेरा ये है
Sir, how to আমি কি করে এনার্জিটা কাউন্ট
एनर्जी की করে বলবে? I don't get it. क्या?
মানে এনার্জি কতটা হয়েছে?
No, you,
থার্ড লাইন যখন মানে ইলেকট্রনটা
obviously that expression is there na, that is delta E equal to 13.6. बोलो. That is what it is.
Oh, okay.
हाँ.
ये नहीं उठणार NF4 ना?
हाँ, understood ना?
Yes, sir.
And
Yes, sir.
that we have calculated, you know that part.
Yes, sir.
Yeah. So क्या यार आज पेन थोड़ा ठीक है। तो ये लाइमन लाइन के बारे में मैंने जितना भी मुझे बताना था मैंने बोल दिया आप लोगों को, ठीक है? क्लियर है ये बात? हाँ, तो ये मेरा न्यूक्लियस है यहाँ पे। अच्छा, अब एक और बात समझो यहाँ पे। कुछ एक और टर्म है जिसको हम लोग कहते हैं लिमिटिंग लाइन, मार्जिनल लाइन, लास्ट लाइन। क्या है वो? अगर कोई लाइन है जो इनफाइनाइट डिस्टेंस से आ रहा है, जैसे कि मैंने कहा इसको क्या एन इन्फिनिटी था ना, तो ये जो लाइन है आपका, ये वाला, बच्चे समझेंगे, ये जो लाइन आप देख रहे हो, दिस इज द मैक्सिमम एनर्जी, आई कैन से दैट वे, दिस इज ई मैक्स। माने क्या ये म्यू मैक्स भी होगा, म्यू बार मैक्स भी होगा, लैम्डा मिन होगा रे, बोलो। सबके लिए क्लियर है ये? हाँ। सो यू रिमेम्बर दोज थिंग्स आई टोल्ड यू, एनर्जी के साथ वेवलेंथ का क्या वेरिएशन है, कैसे रिलेशनशिप है, राइट? ओके, सो इसको हम लोग फिर से कहेंगे क्या, ये हमारा लास्ट लाइन कहेंगे हम लोग इसको, क्या कहेंगे? लास्ट लाइन। सो दैट इज हाउ योर सम्स विल कम, मार्जिनल लाइन। ओके, दीज आर वेज ऑफ कंफ्यूजिंग यू, राइट? और इसको हम लोग क्या कहते हैं? लिमिटिंग लाइन। सो दीज आर द टर्म्स।
গ্যাপ যত বেশি বা যত দূর থেকে আসবে তত এনার্জি বেশি।
हाँ, that's it. That's it. Yeah. Okay. So now, similarly, there is another line that is called. These are lines given by the name itself is giving you the scientist who has discovered it. Okay. So or identified these lines. This is called Balmer line. N1 बोला था तब, अब क्या है? अब मानो कोई लाइन है जो Ni उसका वैल्यू ग्राउंड स्टेट का है, माने Ni का वैल्यू है यहाँ पे 2 और Nf जो है यहाँ पे 3, 4, 5. So all the lines that are falling to n equal to 2. It can come from any excited state, but it is falling to n equal to 2. Such set of lines will be called as Balmer lines. ठीक है ना? Such a set of lines are called as Balmer lines. Okay. Now one more thing, these lines, they fall under the region, we call this as UV region. Okay. These Balmer lines, where, as I have said, n equal to ni equal to 2 and nf equal to 3, 4, 5 or infinity, these set of lines, they will fall under what we say visible region. So they will ask you in a question that which set of lines in a hydrogen spectrum they belong to UV visible region or UV region. Okay, which set of lines belong to visible region, then you will say it is Balmer lines that belong to visible region. Okay, bolo. Next line, suppose here, so if you say the first Balmer line, then what will you say? It is N2 and the gap between N2 and N3. This is the first Balmer line, bolna. Similarly, if you say gap between N2 and 4 is what? Second Balmer line. So that is how they will ask you questions now. It is very easy that way if you just understand the analogy. Okay. Then I am saying something called Paschen series. Okay. It's better to say lines. So यहाँ पे ni क्या होगा? कुछ idea? lines.